So in this video we're going to look at some of the introductory material review. Here are some of the major helpful reminders that you'll find, some of the different properties, as well as just some things to help you remember. Like when we add and subtract terms, the terms have to be identical for us to actually add or subtract the coefficients. For example, when I look here at, I have a 5x and a 7x, they both have x, so that becomes 5 plus 7 is 12. But I can't add 12x plus 4y because they have different variables. When I'm multiplying though, I can multiply all the common terms, but it all comes back together. So that's the difference between addition and multiplication. So when I look here, I have the 5x times 4y times 7x. I could really look at that as having multiplication between every single component. So I'd multiply my numbers, I'd multiply my x's, and then multiply my y's. So 5 times 4 times 7 is 140, x times x is x squared, and then y is y. And then I can combine them all back. And this is possible thanks to the associative property. So let's look at just a few examples of simplifying. When I look at my problem, I do want to remember order of operations. So if I have it here, I first want to look at this distribution. So I'm going to take the 5 and distribute it to both of these terms. So now I have 3x plus 4y minus 9x plus 10y plus 15. And I'm going to combine like terms. Well, my like terms, I've got the 3x and the negative 9x. That's negative 6x. Then I've got the 4y and the positive 10y. That's plus 14y. And then I have my plus 15 because it has nothing to combine with. Now when I look down here at the next one, I have quite a bit going on, and I've got to pay attention to what I'm doing. For example, when I multiply two exponents that have the same base, that's the same thing as saying 3 raised to the 2 plus 3, or 3 to the 5th power. And if I do 3 to the 5th power, I will get 243. Now here when I see the parentheses raised to the 3rd power, that's the same thing as saying 4x squared times 4x squared times 4x squared. So what I'm looking at here is 4 cubed times x to the 2 plus 2 plus 2. Now 4 cubed is 64, x and then x to the 6th. These terms are different, so I would not add them together. Now two other examples here. If I've got 4x squared times 2x raised to the negative 3rd, that negative 3rd tells me that what I'm really looking at is 4x squared over this quantity 2x cubed. Now I have to remember that when I do the cubed, that's really the same as saying 4x squared over 2 cubed x cubed. Now that gives me 4x squared, 2 cubed is 8, x cubed, and now I simplify. I say to myself, what's 4 divided by 8? 1/2. And then when I look at my exponents, this is like saying, I say I'm going to subtract my exponents and I want to keep the variable in the greater value. So in this case it's the cube. So I end up with 1 over 2x. In my last example here, I want to add and combine all like terms I can. What I have to remember though is that I have a negative that needs to be distributed to each of these terms. You can think of it like a negative 1. So I look at this as 3x squared minus 5xy plus 9y cubed minus 7xy minus 8x minus 4x squared. Now I want to combine my like terms. I have x squared and x squared. That's negative 1x squared. I have negative 5xy, negative 7xy. That's minus 12xy. And then if I look, there's only one y cubed, so that's plus 9y cubed. And then I look, there's only one negative x, so minus 8x.